we discuss the function returning object? Is this what has been discussed in the last class?
Yes, sir.
Then the static data member, is this what has been discussed? The static data member, has it been discussed?
No, sir.
Then we will focus on this. So the way we have used the static members in C by using a keyword called as static. So in the similar fashion, the C++ also permits to define a static data members within the class by using the same keyword called as the static. So whenever any data member is going to be declared as a static, so there are certain things that we need to keep in mind. So the first thing is that, so whenever any data member is being associated with a static keyword, only one copy of the data is being maintained for all the objects of the class. For an example, let's call for an example, let me open up a notepad. So for an example, so let's call we have created a class employee. In this employee class, under the private one, we have created called as employee number. Then we have created something called as a static string country. Then some other definitions are there. Now, when the class has been created and when we need to create a object of the class, so let's call the object of the class is, let's call we have created an employee of E of 10 here. So when that means in this case what has been happened? So all total there are 10 object has been created. So these 10 object will have the independent value of EMP numbers. That means E of 0 will have one employee number, for an example 1. Similarly E of 1 will have another employee number called 5. Then E of 2 will have another employee number called as 11. But when the static is being created, like the one which you have depicted over here, so there will be only one copy of the this country will be created, and this copy will be shared among all the objects. That means for E of 0, if the country is India, then E of 1, the country will be India. E of 2, the country will be India as well. So this is what is in the first point. Only one copy of the data member is going to be maintained for all the objects of a class. Only one copy of the data is being created in memory. The same thing. So that is why, because this data member will be equally shared with all the objects which has been created for a specific class itself. Then all the objects of the class share the static member. So that means all the object will be having the same value. So if one of the object is being updating the value, for an example from India to, for instance, Canada, that means for the remaining instances the value will reflect as Canada as well. So then when the first object of the class is created, all the static members are initialized to 0 if no other initialization is being present. So that means, so when the first object, so we have created E of 10 here. So when the first object, that means the one which is at the index 0, that means when that object is going to be created, so the integer float are going to be defaulted to initial value of 0. Then if it is being a boolean, then it will be initialized to false. If it is being a string, then it will be initialized to empty. So the initial values will be assigned to the variable if no other initialization is being present. So that means if you want the initial value should be something different, then you have to explicitly mention the value for the static data member. If it does not provided, then whatever the default value for the data type, that is what will be associated with it. Then the static data members are visible within the class, but their lifetime is the entire program. So that means what this point is trying to convey is that, so as long as the class, the binary code of the class does exist in the program, so this will be visible, and their lifetime is going to be throughout the program. That means unless until the program has been successfully ended, that is the integer main, where in the function when the last encounter return 0, so the lifetime is going to be till that point itself. So the memory for the static data member is allocated for the class and not for object. The way we have seen that the memory will be allocated when the objects are going to be created. In such instances, the object will have their own value of those data member. In contrast to that, whenever a static data member is being mentioned, which is being for a class, then there will be exactly the memory for those static data members will be allocated per class rather than per object. Okay, so what we will do, we'll just quickly look at it with an example here, then it will be more clear to us. Okay, now you can see, so we have a class called as the sample. So in the sample one, so we have a count is being it is nothing but a variable or a data member which is being used here. Then we have two function here. One of them is being called as get count, and the second one of them is being called as the put count here. So these are the functions. These are the member function which were declared within the class. Then these are the definition which has been come across. So when we are going to have the definition, so the get count is means, so this is will be just incrementing the value of count by 1. Then the void put count which is being done here, so in this case it is what it is trying to do, it is trying to initialize the value of the count to 1 here. Now what has been happened here, so simple sample, so we are creating three objects here. So when we are creating three objects, so we will call s1 dot put count. So that means what will happen, for the object s1 the value of count be initialized to 1. For the object s2 the value of this could be initialized to 1, and for the object s3, so the value of count will be initialized to 1 itself. Now when we try to call the get count, then what will happen, so it is going to return what value it will return when we write s1 dot get count, so it will just increment the value of count by 1. So the count of value was earlier 1, then it is being a pre-increment 1, so it will be reflecting as 2 here. So this one will reflect 2, this one will reflect 2, and this is the one which will be reflecting 2 here. So that means since there are three objects are being created, so all these three object is going to reflect a value of 2 each here. Okay, so this is what is being demonstrating a non-static data member. So is this clear to everyone? This is the traditional program, so which we have not used any static data member utility. So is this program is clear to everyone?
Yes, sir.
Sir. Okay. Then what we will do, we'll try to the same program here. So in this same program, what has been done here? So under the private one, what we have done here is that, so we have created the count, is this count which we have done it here. So then this is the one which will be created as a static here. Okay, in the earlier cases what has been done, so we have just created an integer count here, then we have a the get count function here, and in the earlier cases we have a put count function. That put count function was being initializing the value of count to 1, but in this case we do not have a put count function here. Then subsequently we are going to define the function here. So in this function, what will happen, we are just incrementing the value of count by 1 here. Then what has been happened, so three objects are being created here. So when the first object has been created, so the value of count will be initialized to 0. Then when the s2 object is being created, no changes to the count value. When s3 object is being created, no changes to the count value. So that means when the program control has successfully executed this, s1, s2 and s3 will share a common value of count which has been initialized to 0. Okay. Now when we call s1 dot get count, then what will happen, so this one will be incremented by 1. So that means in the first one the value will be printed as count colon 1. Then when this function will be executed, it will print that count colon 2. Then when this function will be executed, it will print count colon 3. Why? Because this count variable which has been used here is going to be shared among all the objects here, and hence for every call to with the object s1 and s2 and s3, the value of count will be incremented by 1 here. Okay, so is this clear to everyone? Is the concept of the using of the static data member, is it clear to everyone?
Yes, sir.
Okay. Then what we will do, so we understood the static member, data member. Then we will understand what is meant by a static member function. So by declaring a member function member as static, you make it independent of any particular object of the class. That means what we are trying to tell here is that, so whenever any functions which is being defined as a static, then that means a static is the keyword which will be added up to the definition of the function, or during the declaration or during the definition of the function. So what it is trying to tell here is that, so when a static function is being encountered by C++, then it will be the independent of the object. That means it does not have to rely onto the object in order to invoke the function. So therefore a static member function can be even called even if no object of the class does exist, and also the static functions are being accessed using only the class name and the scope resolution operator. So that means this point is telling that, so whenever any data member is being created, in order to access this, you have to definitely create an object. But for to access a static member function, it does not really require somebody to create a object and to access it. So however, so the static member function can be called or can be accessed with the combination of the name of the class and the scope resolution operator. So a static member function can only access the static data member, other static member function, and any other functions from the outside of a class. So that means the last statement, what it is trying to tell, it is trying to tell that, so if a function is being designated as a static member function, then that static data member function can only access the static data member, can access the static member functions, other member function which may be defined within the class, or it can even call any other functions which have been defined outside of a class itself. Okay, so let's understand the concept of a static member function with an example here. Okay, so in this case, what has been done here? So we have created a class called as the a demo here. So in this demo class, we have created two static data member, something called as integer x and then integer y. These are the two static data member that has been created under the public access specifier. Then we have created a static member functions. So this member function is essentially just flushing it out the value which is being associated to x and y here. So you can say that this it is just printing it out what is the value associated to x, then what is the value associated to y itself. So this is what is being the class definition, which name is called demo. Then the next thing what it is trying to do, so as we have seen that, so a static data member can be by default initialized to 0 when the first object has been created here. Suppose we wanted to override this, that means we intend to associated the static member variable with a values, with other values, that means other than the default value. So that is why what we have done here is that, so we have clearly mentioned that the demo is the name of the class. We have used the static, we have used the scope resolution operator, then x is being nothing but the static data member which is being a part of the demo class. X is being defined as a integer here, so that is why we are also assigning a integer here. Then we are initializing into 10 here. The way we have initialized the value of x to 10, in the similar fashion the y value has been also initialized to 20 here. So these are the static member initialization which has been done outside of the class definition. Then what we will do, so we have created an object of it. So when we have created an object of it, then what we have done, so accessing the class name with the object name. So that means what it is trying to tell, so it is trying to flushing out some message here, and this is to demonstrate that this print function which is being a static member function can be invoked with the object. So this ob is being nothing but a object here of type class demo, and this print function is being called up with the help of a object. That's the first way. The second way is that, since we have discussed, it is not mandatory to create an object in order to access the static member function. So that is why in the second instances what has been done is that, so we have just called the static member function with the help of the class name. So in this case a message has been just flushed it out to tell that, so the printing is being called up through the class name. So that means, so here in this case the name of the class is being called as the demo, then the scope resolution operator has been used here, and then the static member function whose name is being print here, that is what has been getting printed over here. Then once the job is over, then we are just returning a value of 0 to the caller of the function itself. Okay, so is the program is clear to everyone? Is this program is clear to everyone? The demonstration of a static that function.
Yes, I got it.
Okay. Now, it is useful when you do not want to create an object just to execute few public function on it. So this is mainly the case of a helper class that contain public function to do some repetitive and some general work, but do not need to maintain any state between the call. So basically the what is the uses of the static member function. So the uses what it is trying to tell is that, so whenever there is a need in your program to create some sort of a helper classes. Okay, so the what is the helper class? For an example, suppose there is a temperature in one unit which has been given. and you need to convert into a different unit. For an example, some Fahrenheit to centigrade, or maybe the reverse, that means centigrade to Fahrenheit. Okay, so that means let's call, suppose you are going to deal with the temperature in certain program, and the input has been given maybe in the Fahrenheit or maybe given in the other unit. So you can write up a helper class, and you can write up a function which be the static function, which will just convert from a different unit to either Fahrenheit or to the centigrade itself. Another example is going to be, so let's call, suppose we wanted to keep track of some monetary amount, and the input has been given in US dollar and in other currencies. So you can write off a helper function which is called as convert to INR, and which will take that the amount, then the country, I mean the whichever country, which value or the monetary value has to be converted into the INR terms. So that is what it will, it will, the exchange rate as of today, so that you can use it, by which you will be able to calculate the monetary amount in the form of a INR. Okay, so these are the few classes, helper classes. Somebody can write it down, and it is not necessary for the helper classes to be defined to be the member function as a non-static one, because it does not expect it to hold any state variable. What is a state variable? State variable means the member variable. It does not need to store any state variable. So that is why just a function has to be mentioned here, which is expected to do some helper related functionality. So that is why this is what is being treated as the best use cases of the static member function. Am I clear? Is it clear to everyone?
Yes, sir.
Okay, let's understand what is meant by the static object. So declaring the object as static, it essentially what it does, it initializes the class data members to 0. So as a consequence to it, all the associated numbers are going to be initialized to 0. That means whatever is the default value for the data types or the inbuilt data type, that the default value will be initiated. So that is why we looked at it. Then what is meant by a static object with the help of an example here. Okay, so now let's look at it here. So we have created a class called as the beta, and in this beta class there are three member variable has been defined called x, y and j. Then we have a, under the public access specifier, there is a function called as the plus. So what it is trying to do, it is just incrementing the current value of x to 10, then incrementing the current value of y by 15, then incrementing the current value of z by 20. Then the show function which has been used here, it is just flushing it out the values associated to x, y and z. Then essentially what we are trying to do, so we are trying to create a static object here. So to create a static object, one need to use the keyword called as the static here. So in this case, the keyword static has been used here. Then the beta is nothing but the name of the class. Then the beta obj is nothing but the object which is of type class called as the beta here. Then what we are trying to do, so we are just calling it as the beta obj dot plus here. Then in this case what has been happened, so when we are creating a static object here, the default value of x will be the value of x will be initialized to 0, y value will be initialized to 0, and then the z value will be initialized to 0. That means when we call the function here, what will happen, x is equal to x plus 10. So that means new value of x is equal to 0 plus 10, which will be 10. Y value will be y plus 15. So earlier value is 0, so 0 plus 15. So the new value will be 15. Then z value will be called as the 20 here. So because 0 plus 20, which will be becoming to 20 here. then in such a cases what will happen? So this is the new value of x, y and z will appear. Then we are just calling a beta obj dot show here. So in this case what will happen? The value of x will be printed as 10, value of y will be printed as 15, then the value of z will be printed as 20 here. This is what is the output that this function will be able to demonstrate. So is this program is clear to everyone? Is the concept of static object is being clear to everyone?
Sir.
Okay. Okay. Then what you will do? So we will understand something called as a friend function. Okay. So one of the important concept of object oriented programming is being called as the data hiding. So that means a non-member function cannot access an object's private or protected data. That means one, it is what it is trying to tell here is that, so let's call what is a non-member function. So let's call this is what is the one which you have defined it here. Okay. So what is a non-member function? So I can define something called as the get employee. So what is this function? This function, so this get function, it does not associated to the class employee here. So that means in this case, I cannot access something called as the employee number and country. So this is what has been called as a non-member function. But if the same code we are going to write it here under the public access specifier. So let's call if the same code is being written either under the private or the public access specifier, then we will be able to access the employee number and then the country. Okay, so that is what is the first statement it is trying to tell here is that, so a non-member function cannot access an object private or protected data. So the private data, I mean the under the private access specifier or the protected access specifier, the data member which is being defined under those sections. But there is a mechanism which is being built up in C++ programming to access the private or the protected data member from a non-member function. So this is what is being done using a friend function. So that means what this is trying to tell here is that, so if this function is being defined here, let's call this function is being defined here. So that means we have a utility or we have a mechanism by which this get employee function can be able to access the employee number as well as the country, provided this employee is being a friend to get employee function. Okay, considering another example here. So in your class, so there will be some good friends among each other. Okay, so let's call a student X is being a good friend of student Y. Then the student Y may be knowing about some secret about student X. Similarly, the student X also may be knowing about some secrets about Y. But the secret of X and Y is not available or does not, I mean the it's not available or being unknown to the friend called as Z, the friend called as A, the friend called as B, because the A, B, C and the Z, these are being not treated as the friends of X and Y. So therefore the same concept is also being exist in C++. So that means if you somehow need to define this function as a friend function, then this friend function will be able to access the data member which is being defined either under the private or under the protected access specifier. Okay, so this is what we need to look at it here. So if a function is being defined as a friend function, then the private and protected data of a class can be accessed using the function. So the compiler knows a given function is a friend function by the use of the keyword called as the friend. So in C++, to let the C++ compiler to know that a function is being designated as a friend, then you want need to use the keyword called as the friend here. So that means when the C++ encountered a function which is being associated with a keyword called as the friend, then that is what it will be treated it as a friend function. So for accessing the data, the declaration of a friend function could be made inside the body of the classes, or it can be anywhere inside the class, either in the private or in the public section, starting with the keyword called as the friend here. So to understand the last statement what has been written over here, so we need to understand this with the help of a example here. So let's quickly jump into the example so that our understanding on the friend function will be pretty much clear itself. Okay, so in this function, so what are we trying to do in this function itself? So we have created a class called as the box, and in this box, the under the private access specifier, we have defined a data member called as the width here. Then subsequently, under the public access specifier, so we are telling that, or we are letting the C++ compiler that the print of width is going to be a friend function, and this is what is going to take up a object of type box. Then similarly, there is another function called as the set width here. So this width is going to is taking a double value here. So both of these function member function. So this is what is being a member function, and this is what is being a non-member function, because this non-member function is not going to be associated with a class name. But this declaration has been come here to let the C++ compiler that this print width is nothing but a friend function by which he has been given the permission to access the private as well as the protected member variable. Then what you have done, so in the set width function, so we have taken up an argument called as the wid, so which is going to set the width here. This is a pretty simple example here. Then in the print width, you can see it here, the print width function is being a non-member function because it does not associated with any one of the classes, but this print width is already being declared as a friend function for the class called as the box here. So that is why it is taking a box argument here, and then this box argument, what it is trying to tell, it is trying to access the member variable called as the width here. So you can see it here, this box dot width has been called over here, and this width is being nothing but a private data member. So that means what we are trying to do, so we are explicitly designating the print width as a friend function by which it will be accessing the data member as well as data member of belongs to private or protected access specifier. Then in the main function, what we have done, we have created an object called as the box here. Then to that object we are setting a width by passing a value of 10.0 here. Then finally we are just calling the print width function here by passing the object here, and this object, this function is being treated as a friend function by which it is being able to access the private as well as the protected data member. Okay. So is this is being clear? Is the concept is being clear on what is meant by a friend function?
Sir, what is the
Yes.
use of friend function?
The use
We-
is that, so let's call. a friend, a two students become friend to each other. For an example, suppose I have a good friend in my faculty community, okay, whose name is X. So let's call within KIT University, if something is being happening, I cannot share with all the faculties, but I can share only with a faculty called as X. Okay, so this practice is being not being considered as a good practice in C++ community. But in any cases, for an example, due to some regions, you could not able to define or you could not able to associate a member function, but you wanted to designate it as a non-member function. Then a non-member function to access a private data member. So we are explicitly making it as a friend function. Am I clear?
Yes, sir.
So this is what is being called as a friend function. Then let's understand what is meant by a friend class here. So similarly, like a friend function, a class can also be made a friend of another class using a keyword called as the friend. So a friend class can also be able to access the private and the protected members of another class in which it is being declared as a friend. So it is sometimes useful to allow a particular class to access the private member of a other class itself. So the way we have discussed the friend function in the similar function in the similar way, the friend class also being applicable here. Now let's look at it with a very pretty simple example here. So in this case, we have defined a class called as the A. Then in this A, we have under the private access specifier, so we have defined a data member which is being initialized to 0. Then under the public access specifier, we are clearly calling it out that there is a class called as the B who is going to be the friend of class A. Okay. So in the earlier classes, what we have done, we have written of a function we are associating with a keyword called as a friend. In the similar fashion, if you want to designate another class which is expected to invoke or which is expected to access the 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 member variable or belonging to private or protected access specifier, then we need to designate it here as a class which name is being B and which is being treated it as a friend class itself. Then finally what we have done, so class B here. So in the class B, what we have done, we have created a under the private access specifier, we have created something called as a integer B here. Then in this case, what we are trying to do, we are trying to define a function called as the show here, and this show a here, what it is trying to do, it is calling by reference. It is the call, the way we have studied call by value, call by pointer and call by reference. So in this case, it is taking, it is being called with a call by reference here. So in this case, what we have done, so since B is a friend of A, it can access the private member of A. So therefore, we have defined stdc out here. So we are just trying to associate what is the value of A here. So then x dot A. So remember this A is nothing but a private member variable, and we are still being able to access the private member variable of the class A since B is being designated as a friend class here. Then in the main function, what we did, so we have written a, that means we have created an instance or the object of class B A. Then we have created an instance or the object of class B here. Then using the instance of class B, we are calling the function called as the show here by passing the object as A here. Then what value it will print? It will just print it down the value of A is equal to 0 here. Okay. So is this concept is also clear? Is the concept is clear on what is meant by a friend class?
Yes, sir, clear.
Okay. Now, what we will do is that we will study something called as a function with default argument. This is what we have already discussed in the function in the unit 2. We have already discussed that what is meant by the function with default argument. So this is just to illustrate you that how under a class this can be also called up. So in this case what we have done, so the sum function which has been written here, so the b and c were being given a default value. Then what this function is expected is being doing is that it is just summing this and it is returning the value. So just to explain or just to call the function, this is what we called up. A is the first one which has been created here. Then we are calling a dot sum. Then we are passing 1 here. So when we are passing 1 here, the default value of b will be 10. Then the default value of c will be 20 here. Then this is what will print 31. When we are calling a dot sum 1 and 2 here, the value of a will become hold 1, the value of b will become 2 here. So then it will be 1 plus 2 which will become 3 plus c value is being 20 here. So it will be 23. Now when we are calling c out a dot sum 1 2 3 here, the value of a will hold 1, value of b will hold 2, and the value of c will hold 3. So in this case, this is what will flush out something value of a 6 here. Okay, so this is which has already been discussed in the earlier unit, but this has been again repeated to explain you from the perspective of a class here, class and object here. Okay, so is it clear? The default argument with respect to class and object, is it clear to everyone?
Yes, sir.
Okay. Then function overloading. So the function overloading also has been discussed in the earlier class. So again, so to illustrate you with the help of a class and object, we are just doing the function overloading. So we have a add function which is being taking two argument of type double. Then we have a another add function which is being taking two argument of type integer and each returning a integer one. So in the earlier it was returning a double. Similarly, this is a another add function, so which is being taking three argument and which is each of them is of type integer. Then this is also being returning an integer here. Then what we have done, so those functions are being overloaded here. Then we are creating an instance of a here, then we are calling a dot add 1 2. So when this function will be invoked, so this function will be called up. Now when the second function which has been called up with a value of 1.5 and 2.5, so this double function, the return type is being double, this version of the add function will be called up. Now when the third one, the add 1 2 and 3 has been called up, then this is what is the default value that will be called over here. Okay, so is the function overloading is clear?
Yes, sir.
Okay, then comes something called as a nested class. So we have already discussed or we have already studied what is meant by a nested loop. That means a loop which is being residing under a another loop. That means there is a, I mean that is what is the concept is being called as a nested loop. So similarly, so the nested class is nothing but a concept in which a class is going to be declared inside a another enclosing class. Now for an example here, so this is what is being a class called as the host. Then under the public access specifier we have defined a another class which is being called as the nested here. So within the nested class here, under the public access specifier we have defined a function called as the print me. Then the print me is just basically flushing out a message here. Then when this the print me function has to be called up here, so we have to go via the outer classes. Okay, so that is why, so the host, which is being nothing but the parent class, then we need to use the scope resolution operator here, then we can go to the nested, which is being called as a inner class here, or that is what has been defined within the another class here. Then we are being creating an object called as the foo here. Then by using the object foo here, we are just calling it out a print me function. Then finally it is what is being returning a 0 here. Okay, so writing a nested class in C++ is generally avoided. Nobody in industry, nobody prefers to develop any sort of a inner classes. So this is just, this is just for your information, that the concept of a nested class does exist from the perspective of C++. Okay, so is this concept also clear? What is meant by the nested class? Is
Yes,
this
sir.
clear? Okay, very good. Okay, then comes something called as a local class. Okay, let's understand what is meant by a local class. So a class which is being declared inside a function when it will becomes a local to that function, and this is what is been called as a local class from the perspective of a C++ here. Now if you look at the example here, so in this example what has been happened, so we have defined a function called as the fun here. So within the function definition here, so we have defined a class called as the test here, and there are some member variable within the class here. So in this context, the class which is being called as the test is being called as a local class itself. Okay, so now what we will do, we will just simply go through an example to understand that what is meant by a local class here. So in this case what we are trying to do, so we have defined a global variable called as y, then we have defined a function which is going to be accessible to all, that is what it is being called as a g here. So this is acting as a function prototype. That means the definition of the g is being will come after the main function. So this is the g is being nothing but a function prototype. Then in the integer main function what we are trying to do, we are just calling the g function here. Then finally this is the return 0 statement which has been come over here. Then in the void, then in the g function what we are trying to do, within the declaration of it what we are trying to do, so we are just trying to create a class which is being called as the a local class here. So in the local class what we have done, so we have written something called as a put function, and we are also written something called as a get function here. So what it is trying to do, so it is trying to set the global variable. So the global variable means what it is trying to do, so the y is being defined as the global, that means this y we wanted to set the value. So that is why I have discussed this in one of the classes, done the use cases of the global variable. So that means in this case this y will be treated as this is the one, that is the global variable. Then whatever value that has been passed, that will be stored here. Similarly, whatever value that has been stored in y, which is been treated as a global variable, that is what it will be written here. Then this AB which has been written here, what is that AB? AB is nothing but a object of type local here. So we have not created with something called as the local AB. So that means during the definition of the class called as the local here, we have simultaneously created an object which is being called as the AB here. And finally what we are trying to do, so we are trying to call the put function here. So in the put function we are just passing a value of 20 here. Then finally the cout statement over here, what we are trying to do, we are just trying to reflect that what is the value of y which has been already stored with the help of a put function here. So that is why we are just calling the get function here. So abg dot get function which has been called over here. So in this case the output of this program is going to be the value assigned to y is 20. Okay, so is this clear on what is meant by the local class? Is this clear on what is meant by a local class?
Yes, sir, clear.
Okay, so this local class is also being avoided in C++ context. So in industry, so they do not prefer to write any sort of a local classes itself. Okay, then something called as a this pointer. Okay, so now let's understand. So we have already discussed what is meant by, we have in C we have already discussed what is meant by the pointer. So we will be discussing in from the C++ perspective on what is meant by the this pointer. Okay, so let's understand what is a this pointer first. Then we will be jumping into the two scenarios in which the this pointer is being useful. So the this pointer is being passed as a hidden argument to all non-static member function call. That means what this is trying to tell here is that, so all of you know what is meant by the cookies in the website. So when we are trying to use any website, the web browser is essentially store your information like login ID and the password. So if you first time save it, the next time onwards it will not ask you for the user ID or with the password. So that means your user ID is or password is becoming an hidden one. So that hidden value which is being stored in the cookies of in the browser. So considering that scenario, so this pointer is being essentially it is being passed as an hidden argument to all the non-static member functions call. That means this pointer is a concept is being applicable to all the non-static function which is being defined within the class. So that means this pointer is a concept which is not applicable to the static member function, and this is what is being available as a local variable within the body of all the non-static functions. So that means, so this is the whenever this pointer is being passed on, so that hidden argument is being passed as a local variable within the body of the all non-static function. So therefore, the this pointer is always being treated as a constant pointer which is expected to hold the memory address of the current object. That means in the current object, whenever we are performing some operation, that is what is going to hold the current object memory location. So in a way we can say that this function is not available in static member functions, as well as the static member function can be called without any object. So these are the two instances or the two circumstances wherein the this pointer is going to be primarily used. So the first use is that, so whenever any local variable name is being same as that of a member name. So let's understand what is meant by this function over here. So if you look at the example here, so the test is being a class, the name of the member, the data member, which is being called as a x here. Now the integer x, so this is what is being a another the same name, with the same name the argument has been passed here. So when we write x is equal to x, for an example, this is what you're going to write, x is equal to x. Then how come the compiler, I mean the C++ compiler, will come to understand whether the data member is being initialized with a argument, or the argument is being getting initialized to the data member. So it will create a confusion in the mind of the C++ compiler. So we need to resolve this ambiguity. So to resolve this ambiguity, essentially what we need, so if something is being passed on as an argument, and the intention of this is to assign the value of the argument to the data member which is being called as the x here. So therefore this, then the arrow mark which is being written over here, so this is what has been used in order to store the value of the argument to the data member here. So therefore it is being written here with a comment. So this pointer you use to retrieve the object x hidden ax, which is being hidden by the local variable called as the x over here. So in this case, if you pass on with a value of 10 here, then this x will be assigned with the value of 10 here. Then finally, void of print which has been written here, so we do not need to call it with the this here, because there is a ambiguity in this, in the set function here, and since there are no argument which is being passed on with the same name as that of the data member, therefore it is not required to associated with the this. But you can, so you can also associate it with this, but it is not going to make any sense here. So then what we have done, so we have created something called as a test obj here, then integer x is equal to 20, then we are passing the obj set x is equal to x here, then we are just plusing the print value over here. So in this case, when the program will run, so it will print x is equal to 20 here. So is the first example is clear on the uses of the this pointer? Is it clear to everyone on the uses of this pointer?
Yes, sir.
Yes, sir.
Okay. Then the second example is that, so when we are going to return a reference to the calling object. Now let's understand this with the example here. So this is a test is being used here. So in this test we have two member variables x and y. Then this is what is being called as a constructor here. So the concept of the constructor we will study in the classes to come. So you can see this is a test. The test is being, it is equal to as a function here, but this is being used as a constructor. So constructor means it is a specialized function whose name is being matching with the name of the class itself. So this is a constructor, and this is what is being called as a parameterized constructor. So this parameterized constructor is being taking two values here, x is equal to 0 and then y is equal to 0. These are the default value. Then this is what is being using the this pointer here, because this x and this x matching, this y and this y is also matching. So that is why we need to make use of the this pointer here. Then the next one, what we are trying to do, so we are trying to return the current object here. So that means if you look at it here, the value of x has been given with a value of a here. Then we are writing return star of this. That means the current object in whichever location it has been shared, that location will be passed on to it. So let's call, if it has been stored, the current object is being stored at the 8000 location, then the 8000 location will be passed on here. Similarly, the same thing is being happening here. So this is to populate the new value to x, and this is to populate the new value to y here. Otherwise these are the two same function here. Then finally we do have a print function here. So this print function is just flushing out the value of x and y here. Now we'll look at it with an example here. So in this example, so we have created an object called as the obj1 here. This obj1 is being essentially passing the value of 5 and 5 here. So the default value of x and y is becoming a 5 and 5 here. Now you will see, so we are introducing a concept which is being called as a chained function call. That means the way, I mean, if in the DSA you have studied something called as a linked list, which is going to form a chain in the similar function. So the chained function call is being possible with the use of a this pointer. So that means what is being happening, so with the obj1 we are calling this function here. So that means when till this point the function will be called up, the new value of x will be 10 and y value will be continue to be 5 here. Then when this is the one will be called up, so that means this is what will be referring to the one object here. Then so that means then when this set y will be called up here, the new value of y will become a 20 and the value of x will remaining to be 10 here. Then we are just calling obj1 dot print function. So that means when we call the obj1 dot print function here, the value of x will be 10 and then the value of y will be 20 here. So am I clear? Is the concept is being clear?
Yes, sir. Clear.
Okay, so this is what is being a something called as a this pointer here. Then we have something called as a constant member function and then constant object, so which we will be discussing in the coming classes. Okay, thank you very much. Okay, I took here 1 minute extra time which I took it just to complete the this pointer itself. Okay, thank you very much. If you have any question, then you can ask, otherwise the class is formally over.
Thank you, sir.
Okay, then if you do not have any questions, then I am closing this meeting.